Okay, I think I'm good to go. Let's just see what's happening here. All right. Looks like we're good. Let's clean this. Let's clean this view up a little bit. How about that? Let's see here. All right. Let's see. Ugh. Do 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 do. All right, things look pretty good. Yeah. Well, do they look good? I think they're fine. Well, hopefully. All right. Enough chit chat. I want to see, before I forget to try this, I do want to see if this command will actually work. It doesn't look... What have I done? I did something wrong. Dang. Okay, well, actually, now that I have that and no one's really tuned in yet. Hey, it's John. Someone is tuned in. How's it going? I was just about to turn my screen off for a second to try and fix things. Hope you're doing well, John. Dude, I'm so excited for next month. I'm also gonna... I have to configure something for a minute here, and it's just easier to hide the screen, you know? Let's see, what am I trying to do? You'd think after doing this for a while now I'd actually be more organized with everything, but apparently I'm not. Things just keep happening, you know? I keep not preparing. There we go. You doing well? Just reading before a class? You were distracted and saw I was going live. Man, my Twitter... I was doing Twitter announcements for a while and they weren't getting attention, but recently they've started to get a little bit more, and so I'm finally like, yes, okay. People are listening to me. So that's cool that worked. Can't wait for you to come. Yeah, I am, dude. I'm so pumped. It's gonna be great. I think I'm making a really good choice for myself moving, you know. Right. I'm trying to set something up here and then I can get back to the proper situation. Let's edit this one. All right, let's see. I have to try again. Oh man, I'm a I'm a tragic mess. Stuff is not working for me right now. I'm doing my best, I promise. All right, let's try one more. Thanks for bearing with my ridiculousness here. Number one. You're messing with me, but I'll take it. Okay, does that actually lead to my YouTube channel? I think it does now. It's like I'm a professional or something. Oh my goodness. So ridiculous. All right, let's get back to reality. Oh, there goes gravity, etc., etc. There we go. Oh, you're supporting me? You're not messing with me? I'll take it. I'll take it. All right. So, John, what I'm actually working on, so I have this 3D modeler here, and I've got a workflow that I can make code changes and it automatically updates it. Here, I'll make a really obvious change so that you can tell. So here, the length of the tube I changed from 48 to 12, and it automatically calculates the new positions of things. I'm pretty stoked with it. It's really cool. This is a single module from a hydroponics unit that a friend and I are building before I move. It's gonna sit in his basement. He's not growing anything bad. He's growing like kale and spinach and there's various microgreens and stuff like that. So that's what this system is. And I mean, it's a pretty simple construction, but this method of doing 3D modeling I'm pretty happy with. I'm using it to design furniture, modular furniture for when I move too. So it's all coming together. Want to help you garden when you get there? Absolutely, that would be cool. I actually don't do much gardening. I mean, despite having worked in greenhouses and the horticultural industry for a long time, I don't really garden, but I'm sure it's a fun thing to learn. So I'd gladly help you. That sounds really cool. Might actually be a good thing to learn, you know? Let's see here. All right. All right. Oh, I wonder if this is a smart thing or a bad thing to do. I'm tempted to I recorded a new set of footage for my next YouTube video. I have all the footage here. Oh no, I don't have all the footage here. I thought I did. Downloads. Yeah. There we go. Vim props. Anyway, I have a script that automatically edits stuff for me, and I wonder if I should set it up and run it while I'm streaming. I'm just a little nervous that it's a bad idea. You know what? I won't risk it. At least maybe if I get bored, maybe I'll risk it, but that's a problem for another time. Let's swap this out at least. There we go. All right, so learning about food production and preservation is an interest of mine. Also, you've got a weird room that you're thinking of turning into a small workshop and makerspace. Oh my goodness. That is phenomenal. I am so happy to hear that. I'm going to have a heyday, man. That's really exciting. I will absolutely help with that. That sounds like a ton of fun. Dude, there's all kinds of things we could make. Oh my goodness. Man, life is good, dude. Life is so good. So this is a really silly thing that I'm super proud of. I have this document, right, with my code written in it and notes and stuff. I figured out. I drew these like simple illustrations on my iPad and importing and showing the images right in line with the code. It really looks quite cool, I think. And that all relates to, like, it relates directly to the pieces that are defined here. Dang, I'm really happy with how this workflow is turning out. If you can't tell, it's exciting to me, you know. But let's see. What? You know what? Let's do it this way. Let's open up a new file. Let's get to the other design that I'm working on here. It's very clear. Oh, good. Yeah. I hope I'm not like coming off as braggy or anything, right? I'm super happy with this stuff. It's so fun to do. And I think it can be pretty powerful. I'm not sure if this means anything to you, but I can actually make step files with it, which means I could write code that's open sourced and everything, and I could export a step file and send it to like an actual professional manufacturing company, and they would be able to use my designs in their whatever CAD system they use. You can import step files to it. So the fact that I can export step files is like, it's a big deal in like it just how my distribution and working within other existing design systems is really, it opens way up when you can export neutral CAD formats like that. So that's another win too. It's all coming together one little step at a time. All right, let's see if I can get this design file up and running. I think I should be able to. Let's do it like this. Open up a REPL there. John, are you a Kings of Leon fan? I only ask because I don't know what prompted it, but I started listening to their the album Come Around Sundown, I think it is. It was like a total blast from my high school past, and it's just, all those songs have just been stuck in my head, and I've been in this like a nostalgia headspace, you know, but not like the toxic kind, like the, oh man, it feels good to remember some of those times kind of thing. Does that make any sense? Okay, so we've got the REPL open there. Let's do one of these. Oop. Yeah. Let's go. Yeah, you still have that CD? Nice. Yeah, that was one of the bands I listened to a lot in high school. And it's one of those that I'm not like embarrassed that I've listened to, if that makes sense. You've been running to a lot of nostalgic high school angst music. Yeah, that makes sense. I could get behind that. Okay, what am I trying to do here? Capilano, there we go. Okay, so now I need to launch the Watcher namespace. So Watcher, that should boot up the file Watcher. Then I should be able to make changes that compile automatically. Running from my feelings, you know. Oh man. In my experience, my feelings are always faster. But in all seriousness, have you been running for a while now? Because I, it's so lame to say, but I found it so completely true that a fitness routine of any kind is one of the things I'm most proud of consistently. Like, even if it's a small little thing, you know, I think everyone should take pride in some kind of physical activity, and running is totally a good one. That, like, it's accessible, right? You could technically do it in whatever footwear you've got. You could technically do it without footwear if you're bold, and you just go, you know? It's accessible. It's hard, but it's good for you. It's all good. Okay, so now I need to open the right file. This one. Yes? Maybe. Kinda. This one we don't need anymore. That, I forget why I did that, but that looks pretty cool. Just getting back into running. You've been finding it a little difficult to maintain a schedule, but every time I do it is better than not doing it. Yeah, that's the attitude I have too. Yeah, and it can be really hard, especially, I mean, in Canada, it can be kind of challenging, especially this time of year. You know, it could be as warm as 5 degrees outside and you throw on a bit of a sweater and you're good for a nice run. It could be blowing wind and -17 or -10 or whatever, and it's like, do I really want to run in that? So it can be a little bit up and down. Maybe in Vancouver it's a little different, I don't know. But it's been that way around here. Makes it kind of hard to do runs, but still worth it. All right, let's see if changes to this design file will correctly update. Oh, well, correctly is apparently not on the menu, but it is seeing changes anyway. Oh, it might actually not. It might be because it's not rendering anything. Let's see. Let's try this panel assembly. How about that? Panel assembly. Let's do 20 by 20. Thickness of 1/2 inch. Hey, there we go. Oop, it's a little small, but there's something. You're gonna love the weather out there. You're coming at the best time. Fall is a bit depressing. Oh man, what's wrong with fall? Is it raining a lot over there? Is that what it is? I happen to really like fall in terms of the temperature, and the color is really nice. It's a really fun time to do hikes and stuff like that. I think I'll find reasons to enjoy a lot of stuff. I'm honestly not worried about it. I am just excited. Dang, I'm so happy with this. Okay. So what I am gonna do for a moment here is I have to fix this exporter for a moment actually. No, I don't. Just have to load it. All right, let's try. Let's not do panel. Let's actually just do corner. Let's do that. Just nonstop rain. Could last for months, but spring and summer are fire. Perfect. You know what? I can deal, man. I can deal. All right, so let me just try this exporter for a minute. CLJ to step takes a... Wait, why is that not doing anything? Let's see here. Oh, something, that's weird. It didn't compile properly, but hey, we can fix it. There we go. All right, now we should be able to run that. Yeah. Takes a file name, which is design/design.cljc, because I'm good at naming things. All right, let's sanity check that this is gonna actually load the way I want it to. Yes, it's all working. That's exactly what I want. Okay. Perfect. Oh. There we go. So that's a heavy duty corner bracket. Currently at a 1/4 inch thick steel, which is definitely overkill, but it looks nice. It'll weld really nice. Just a solid, like a nice weld bead like that, and there. And then drill and tap these holes. And then those become the inner corner brackets for all the bins. And they form the basis for modular furniture sets. That's the idea anyway. So, using the basic rule of 2-inch square, 1/4 inch bolt mounting, I can kind of come up with different attachments now to build up different types of furniture, I guess, is what I want to do here. So one thing I want is like a caster wheel mount. I want to do handles. What else should I do? Maybe the handles would be a good thing to do next. That's fairly easy. It could be fairly easy. Actually, before I do that, maybe I should, let's model a bolt just to be safe here. 1/4 inch bolt dimensions. Let's do a bolt way up here. Okay. See, this is pretty much what I'm looking for. This is really easy to parameter. Oop. Actually, I don't need that open, nor this. I always know how to get to that, and I do that too. There we go. Let's put it up here. Well, let's get to it. Let's model a simple little bolt. I'm not sure if I might. Well, I'm definitely not going to render the threads as actual threads. I might just do some kind of sort of chamfer magic with it, so that'll be fine. Let's do bolt. Okay. Bolt, thank you. Do I want to go as granular as all this? I wonder. I also have, let's see here. It's somewhere in here. Regular, polygon. There we go. This is easy enough. I can cheat and just copy it into here for now. It's maybe not the wisest move, but it'll do. Let's see if it works the way I want it to. So here I've got the radius and the n. So that n is going to be 6 for hexes. So if I do regular polygon points, r in this case is going to, if I remember correctly, the radius is to the points, not to the center of the edges. So that means I have to do c divided by 2 for, so the bolt size 1/4 inch, c divided by 2 is going to be this. So it's going to be 0.242 is that radius. And the numbers of sides is going to be 6. And that's 1, 2, 3, 4, 5, 6 points. So that looks good. That's looking approximately correct anyway. And we can test it visually by by making it. So let's start with no parameters at all and just do the literally the simplest thing. So let's take regular polygon points, do the same thing, 242, 6, oops. Run that through the polygon function, and then linear extrude with a height. What would the height be in this case? Capital D, 11/64. Which I think I can actually write. Oh yeah, I can. You can actually write fractions in Clojure, which is really nice. I think it'll work. We'll find out soon. That should work. If I just call bolt then, and let's hide. Let's get rid of all that. Ooh, appears to not be working. That's all right. Ugh, I always do that wrong. It's extrude linear. There we go. Ooh, wait, does it exist? Hello? Okay, let's try 20. No dice on that one. Must have missed something. Oh, maybe this might not actually work the way I think it does. I wonder if I have to do map drop last. Ugh, I do. Okay. Let's change this up then. This regular polygon function, I'm just going to make it return a 2D thing because the third dimension is always 0 anyway. So I don't need to drop that. I just need to save it like that, and that should work. And this I should be able to make 0.242 again. With that height offset of 6 like that, it looks, does that look kind of proportionally like a bolt? Yes, it does. That's a good sign so far. So height, let's also center false, so that pops it up. Yeah. What's E now? Huh. I guess E is a fillet. It's like a shoulder fillet or something like that. Let's ignore E for now. I think that doesn't matter too much. D is this height. That's a good start. A is kind of the next important thing. So actually, you know what? While I'm doing this, let's temporarily parameterize this way with a let statement. That's easy enough. Actually, wouldn't it be cool? Okay, I'm gonna try something a little interesting here. Let's do a def bolt lut. So LUT is lookup table. So I'm gonna see if it's smart to, what I want to see, if this makes sense, is have the keys of the map be the bolt size as a number. Actually, can I do that? Let's just double check that that actually will work. I always forget what values are legal as keys. Oh. Can't, oh, right. This is a little bit not smart, but you have to, if I want to now pull that key, I have to do get a quarter, and then it works. It's better than nothing. Let's go with it. What steps are required to get the source code into design CLJ? That's a good question. I'll see what I can do to explain a really simple, what I've done to set this all up, okay? So, first of all, are you familiar with Emacs at all? I'm not sure if that's, if it's new to you. Emacs has this thing called org mode. Org mode lets you do plain text mixed with code blocks, subheadings. The following is a code block, right? And you can do begin source Python, say, for example, and I want to do return 2 times 2. If I can execute that, and oh, it says results silenced. I don't know why. Yeah, anyway, forget about the Python stuff. It's a needless example, vaguely. Okay, so org mode lets me write, it's a plain text file. It's a .org file. I have these things, headings, subheadings, different heading, and I can rearrange like this. I can go to normally I can go to headings. There we go. So I can collapse headings to temporarily hide text. It's all still there, it's just hidden. And I can rearrange things like this. Inside headings, I can put code blocks, Clojure, defen high x, right? String high x. Okay, so this is a function. This code block exists only in the org file, but if I do what's called a tangle, if I do this, tangle /example.cljc, okay, if I save this file, if I save this, there we go, it says refreshed open files there. If I navigate to my project folder, I will be able to open up a new file called example.cljc, and it will have this code block in it. So let me open that up as an example. So in this panel here, this is a different file that I'm looking at, right? And it contains this exact bit of code. So right, if I save this again, you see how it changed right here from high to by? Hello. Sup. See that? The source changes directly. So it's as simple as putting the code into that design CLJ file is as simple as making sure every code block has this tangle here to the file that I want. Okay, so I have a keyboard shortcut set up to make, if I want to add a little section right here, I can do Command S. It'll split the code block, and you see how I didn't have to retype the tangle at all myself. I can nicely make new segment. And what's cool is, imagine I do something like this where you see I have deft pi up here. If I put pi below, and let's say I did here, for example, pi times 2, this won't work. There will be an error if I tried to run the whole source file, because I'm trying to use the symbol pi before it's defined in the file. Okay, well, in org mode, you can just pop the code around in your file, and when it tangles it to the source code, now the code is shuffled around. It appends to the source file in the order that it finds source blocks. At least by default it does that. So you can use it to rearrange things quickly. I can write notes to myself here. This design uses a single params map to specify major dimensions, right? And I can put images in there, all that kind of stuff. So if I wanted to change this file name, I could change it to new file, and now this particular bit of code will go into a new file. So that's how you do that. So I'm making changes to the design CLJ, and it's updating this here. So this bolt, for example, if I change so right now it's rendering a hex. If I change it to 4, save it. Oh, maybe I broke it. I might have broken it. Oh, here. Well, there we go. I was on a roll, and now, and now I look a fool. So something went wrong, but it should be working. I'm running a different REPL here. It's watching the design CLJ file for changes and then running a compiler, and then compiling the code that generates this 3D model. So if there's an error, it's erroring out on a different window, so I'm not seeing it directly. Presumably, I'm missing something simple. Let's see here. Huh. That's cool. What causes the tangle behavior? Oh, so the tangle behavior is a built-in feature of org mode. So if I go Emacs org mode tangle, org mode is a extremely popular. I think it comes with modern installs of org mode, or pardon me, of Emacs. It's a built-in feature. Let's see if there's like a good example here. So it's Emacs. Every window you have open, they're called buffers technically, but whatever, I don't need to use all the right terms all the time. You can attach major modes and minor modes to it. It's similar to like if you're using, say, Visual Studio Code, VS Code. If you open a .js file, VS Code will load the JS syntax highlighting extension automatically. Well, Emacs uses the same idea, but they're called modes. So an org file will start up org mode, it's called. And org mode is a program that will do things like tangling. So it comes from the org mode plugin. And I'm pretty sure anyone who's looked up and tried to work with Emacs for a while has probably at the very least read about org mode, if not used it themselves. It's very popular for a bunch of stuff. I use it to write code and notes at the same time. That's really all I'm doing. Oh, there we go. I figured out why this wasn't working as well. So yeah, so I have a file watcher like I said, and now it's actually working correctly. So you see that this is being compiled from, it's running the whole file and just turning my code into the SCAD data here. So here I could go down to 3. 6 is what I need though. Yeah, so hopefully that makes a little bit of sense. Hopefully that clears up a thing or two for you. If not, keep asking questions if you want. I'll do my best. It clears up a lot. Okay, cool. So this workflow I'm doing here, it like you do not need Emacs to do this kind of stuff. The only thing that's, if you're not using Emacs, you're probably not using something like org mode. You're probably not tangling a file. For a moment, if you let me, I can show you. Imagine I'm not in Emacs. Imagine I'm just in any old editor, and I'm going to open up just my design.cljc file directly. Right? You can edit the source file directly. There's no reason you can't. So here I can if you can imagine I have this open in VS Code, I can make that change and it'll watch the file just the same. It's no different. The only thing is here I can't I can only write notes in comments. That can get messy. So org mode lets you do things like export to HTML, so you could make blog posts with code embedded in it, that sort of thing. So it's something I really enjoy. It's not for everyone. If you don't need to write notes along with your code, I mean, there's not necessarily a purpose for it, but it helps me. It's a fun way for me to think because I can move code around like it's little bits of scrap paper almost, and then I can take all the source, rearrange it in one spot, put it out in a nice structure once things are all more solidified, right? So that's what I love about it. But you can do, like, the basic workflow is there for it, as long as you can edit the files that you're watching, you're good to go. You don't need Emacs for it. Where was I? Oh yeah, I was gonna make a bolt here. And I was gonna try a little lookup table thing here. So what's all that about? So I want to look up. Well, first of all, let me just copy the URL as a reference here so that I have something from, there we go. Du, 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 du. Mm-hmm. Yeah. There we go. Yeah. So the bolt size is going to be the key. So I want to key things like this. What's 5/16 again? I'm not sure what's the right way to key these things. Should I just do it as strings? Or should I do it as the decimal? Or, I don't know. I'm going to think about it, but I'm going to go to the bathroom first for a minute. I'll be right back. There we go. Oh. Uh-oh. Oh my goodness, this stupid office chair. Running over my phone charging cable like a goof. It's tragic. My brain's a little slow with fractions into decimals, so I'm going to cheat well, cheat. I'm going to make sure I just do that. I don't know what the right, you know what? I think probably I'm actually going to start with doing it as strings like this as the keys. That might be smarter. Hard to say, honestly. It's unclear to me what the right approach would be. I'll start with this, and we can always change things out, so no big deal. Oh boy. But the idea is each of these headings becomes a key in a submap, and then the bolt function is just dependent on, you pass in just one of these strings, it looks up the right map, and then gets all the keys from that map and generates the right bolt size. I think that's a smart thing to do. Okay, so what's B? I don't really need B actually, but I may as well include it anyway. Ooh, this is I wonder if this will work. Bolt lookup table source image ref. I think. Ooh, let's see if this works. It didn't work. I have to download the image then, I guess. That's fine. Hey, Mike. What's up? Hope you're doing well today. And it's okay if you're a little late. Nothing wrong with that. I am doing 3D modeling again. I'm pretty stoked about the workflow. Things are working nicely. And I'm getting better results with a little bit of patience, you know? It's good. I'm working on I'm trying to see if I can make a simple lookup table for bolt sizes so that I can have more reliable machine size accuracy and stuff like that. So you can see the models updating live. You've seen that already. I don't know if I showed you that I can export to step files without issues either, or with minor issues. Things are working relatively well. So I exported, actually let me do this. If I do, let's hide bolt for a second. Let's go to panel assembly. No, let's just do a corner. Corner 4 1/4 inch thick. So if I save that, it should render a new piece. So this is a new piece, right? And I've saved that. I can export that to a step file, and it opens up nicely here. And a step file is nice because it's a neutral format, which means this can actually be used in a theoretically in a production, like an actual manufacturing kind of position. In a workflow at a professional place. So I'm just happy about that, and I'm just having a good time. Looks super fancy. It certainly looks like 3D CAD, which is the right way to go. So I'm really excited about that. It's a fun workflow too, because you get nice, like pretty quick feedback, which is really good. The next bits of the next stuff to focus on, or The next things I want to loop back into all this is my SVG stuff, so I can generate SVG files on a web page, so you can download, say, or generate drawings and PDFs and whatnot using nice line graphics and stuff, which you've probably seen me experiment with that stuff before too. So it's all splintered off in little experiments, and I want to wrap it up in a nice package somehow. But in the meantime, this is really fun to work on 3D stuff this way too, and it's all good experiments and good code to be writing. So feeling good about it. So let's try to design this lookup table in a way that's clever. Let's save this image too, just to get a reference here. Oh. That's in Capilano. New folder, please. There we go. Resources. Okay, now I should be able to do this. Hex bolt dimensions dot, is it a JPEG? There we go. Pretty neat. Sticks out. It's like a sore thumb there, but it's okay. I should also say reference image from table from same site used to create bolt LUT lookup table. There we go. Okay. Let's try to, so I don't have to scroll my screen. Let's just do from 1/4 inch to 1 inch and just play around with that and see if it works, and then I can just add to the rest of the table after. It shouldn't be a big deal. Okay. 5/8, 3/4, 7/8, 1. Okay, so now let's build out the basis of this. I need thread length for bolt length. What does that mean? Oh, I see. Oh, right. So this is, okay. See, this is clever. Wait, is it clever? I'm not sure that I love this. Whatever. We'll go with it anyway. We'll just do this. A, stub them all with 1 for now. B, C, D, E, and then F. E min max. So this, see, this F value, every other value is essentially static except maybe E. But E is, I'm going to ignore E because, well, I'm going to put it in the table, but I'm not going to use it in the function just because it's a really, really tiny shoulder fillet here. And I think I can do without modeling that anyway. It's fine in this use case. But here, F is dependent on the total bolt length, which is variable, right? I can choose it, sort of, anyway. So I need to split F independently. It needs to be F min or F small or F long or something like that. So I'll just do F A, F B, and then I'll figure it out after that. So that should be everything I need. Oh, Mike, I think you'll be happy that I managed to actually get something working finally. I have this command. So I actually have a link to the YouTube channel now. If Cobra showed up, I could also mess with him a little bit. I haven't tried this one yet, but let's see. Oh, there's an error in, I typoed something on that one. I'll have to fix that one later. Getting all official. I just have a few. I can't remember if I have a GitHub one. So these things aren't hard to do. I just always forget to do them, you know? Oh, you know what it was? It was an old one. It was links, I think. So that, yeah. So, you know, it's a start. They're easy to do. I just always forget to do them. That's the thing. Now I'm spamming my own chat. Sorry about that. Let's see here. Okay, let's start putting in some values here. So if I were like a legit hacker, I would make a little web scraper, scrape the table, and then parse the table into this instead of manually typing it. But that's maybe a topic for a video or something for some other time, because it's not really worth the trouble right now. In fact, it's probably going to end up taking longer to do something like that than it would to type this out. Now I can plug even faster and better than before. Yeah. Oh man, by the way, like, thanks so much for that. You've been dynamite with that. It's been really helpful. Really appreciated anyway, to say the least. Excuse me. You know what? These are better. These will be better as proper. Well, they're proper fractions. They'll be better if I just make them their decimal value. I think. I haven't memorized the 16th or 32nd values for fractions, so I'm not like some magical expert at that stuff. 5/8 would be 625, right? Yes. 3/4, I know that one. 15/16, 9325. I forget it. 9375. Oh, how I wish I could use metric. What a life that would be. Where am I? 1 1/8. 1.125. What was 5/16 again? 3125. And this one, 1.5. There we go. Oh, this is the most boring part of engineering and design work, is making sure your data is okay and still trying to make sure you set things up correctly and all that. Camille says freedom units. Oh my goodness. So technically I work in unitless units until you have to use it in any other system, then you need units. Freedom units, jeez. Ugh. The frustrating thing is, like, we're officially a country that uses the metric system, but like we use a weird mix of it all, and nothing makes sense anymore. And if you measure in football fields, you have to specify if they're American football fields or Canadian football fields. It's a tragic affair. Everybody loses. I will be bitter about units until the day I die. Yeah, bound to American capitalism. I know. It's a real bummer. Camille says same. Yep. Man, the other day I had to, the other day I bought PVC pipe, right? And so PVC pipe it uses the schedule system. So you give the inner diameter is 4 inches, right? And I said, do you have 4-inch schedule 40? And they're like, no, we don't have that. We have, all we have is PVC drain pipe in 4 inches. So it didn't have a schedule unit attached to it or anything. So it's like, okay, I think that'll work, but then I don't know if the right couplings will fit, and it's just it's so needlessly complicated. Drives me crazy, man. But hey, that's just how we have to roll, you know? Janky? Is that slang for something that I don't understand, or do you mean like janky? Like messed up in general? That one. Oh, okay. Gotcha. The thing is, like, I could do all my designs internally as like in millimeters and stuff like that, but if I ever need to, you gotta leave? Yeah. Hey, thanks for tuning in, John. I appreciate that. I will, I'll see you sooner rather than later, eh? Please have a good one. So soon, yeah. Oh, it's coming quick. And I am ready for it. Oh, jeez. Oh, jeez. That breaks my pattern. That's too many decimals, man. Yo, I don't like it. Bummer. As an American, I believe we need to conform to the rest of the world and get with the times, metric or bust. Mike, you are totally you're preaching to the choir with that one, man. I would love that. I have no idea how to actually make it happen. I mean, I obviously I have no voting power in America or anything like that, but like how do you institute a change like that? I wonder how that would have to go. Cuz it's a good, like, it would be definitely a really great thing to do. But it isn't a zero cost change, right? I guess to get the big fellas in alignment, you'd have to make a case for, okay, using non-metric units, using imperial units costs us X millions of dollars in engineering mistakes a year. The switching cost would be Y millions of dollars over the course of 4 years. And then you start gaining because you no longer have as many engineering mistakes or something like that. That would theoretically be the sound argument, but I don't think there would be a way to go about it. People are so used to Imperial that they'll die on that hill. Yeah, I know. I think it makes me think that, like, you would have to... I wonder if you'd like have to subsidize metric mills and stuff like that. So there's incentive for people to actually produce metric materials, and simultaneously start rolling out a curriculum in schools that use metric units. I have no idea if that would actually work. I'm theory crafting political or economic changes, and I have no idea what I'm talking about. So, you know, your mileage may vary. But oh my goodness, that would be a world I'd happily live in. $11.32. Ugh. There we go. This boring part's almost done. I hope. 1/2. I'm going mad with decimal padding here, just so that I don't break the clean appearance of this. And I'm sure that's a foolish endeavor, because I'll have to change one thing somewhere else, and it'll just throw it all off anyway. But I can't help it. 4364. See, one other, so I'm using a table to... Oh, wait, did I mess something up here? This is 0, not 1. There we go. I'm using a table here to get some values and stuff like that, but from manufacturer to manufacturer, there could actually be differences, right? Like it's not guaranteed that everything will actually be the same. So I'm kind of just banking on things being close enough. It just feels slightly incorrect to do it this way. So I'm going to just do the average of these ones for E. I'm going to average them out. Should be easy to do in my head because, so this would be 0.02 up to half is 0.02. Oop. Then these ones would be 0.04, and then 1 inch is 0.06, right? Yeah. Almost done. All right, these are easy enough to type in. Eight 7.5, 1.125, 1.250, 500, 750, 2, 2.25. All right, and back down. Oh, are these all just a 1/4 inch? Huh. Well, that's actually really easy. But I'll put it in anyway. Hard code it in there for now. Just in case it becomes useful. Right? 1.250. Yeah. Yeah. Okay, that's a table so far. All right, that was boring, but now I can use that, hopefully, to make a better bolt function here. So we just let keys be A, B, C, D, E, F, A, F, B from get bolt lookup table size. So that'll return a map that you can pull all those keys from right away, and then you just assemble. You just do this. So this here is always going to be C divided by 2. This is always going to be 6 because that's the hex. And then the height is always going to be D. So we could just put D there. Okay. And so using that as a rough basis here, let's undo this. Don't want to display that right now. Don't need it. Let's do bolt. 1 inch bolt. Let's do 7/8 bolt. Hey, it does adjust, which is a good thing. Let's do 3/8. Yeah. Quarta. All right. So that's looking pretty promising so far. What I will need also is the bolt size and the total length of the bolt, which will depend. So here I'll just do L will be, oh sorry, F actually will be if L is greater than 6 inches. Less equal, I guess. If L is less than or equal than 6, it doesn't matter which order I specify it, then it's FA, otherwise it's FB. So that's the only logical check you have to do. Okay, but even before then, what I need to do is produce so I'll never need B technically, actually. So just get it out of there. I do need C. That's not a big deal. Using D. I actually won't need E right now either, so I'll take that out of there. Yeah, easy. Good, good, good. All right, so union this hex with let's do cylinder. The radius is half of A, and the height is L. Yeah, we'll start with that. And then we have to translate it 0, 0, L divided by 2 negative, so that it goes down. Okay, let's see how that looks. Let's imagine a 4-inch. Let's turn up the, oh wait, I forgot to do that. Let's put in here, let's do FN 50. There we go. It looks like a bolt. Gotta say. I guess there might have to be one more check here. Let's do it like let's do it like this. L if L is less than or equal to FA FA, otherwise L. I think it's kind of dumb, but I think I'll do it anyway for now. Right, so if I do a bolt 0.1, .75 is the shortest, right? 0.76, yeah. 0.8, yeah. Yeah, okay. I guess that's fine to do it that way. All right, now all we need to do is represent the threaded area. So I actually want to do this a little bit differently. I want this top cylinder to be L minus, let's call it SL here, the shoulder length, or the shank length, whatever it is, and it's just L minus F. Yeah, that should be okay. So this cylinder is SL, like that. Then there's one more cylinder to do, one more cylinder to do, and that is uh, 2.1. Its thread length is, oh no, it's not that, it's just F. It can just be F. F, I want to translate F minus half F minus SL. That should put it at the bottom. Let's see. Yeah, that worked. It's hard to see it though, but that's a pretty good start. So this isn't the only bolt, and there's probably better ways to build up this table, but that's a pretty good start. So let's, I think I'm pretty happy with this. So let's actually change this one more time. It'd be nice to chamfer that, but putting a chamfer on there is a little more trouble than it's worth right now. So let's do it like that. And if I were to turn on edges, ooh, it's hard to see it at all, but that should be okay. Let's export this to a step file to have a quick peek at it there. Yeah, let's have a look. Okay. Is the intention to cut and thread these bolts yourself? No, it is definitely not. The intention is to have an accurate representation of bolt sizes and use those in connection spots so that I know what clearances I might need around connection points. But no, I'm not going to make the bolts myself. That would be tedious. I don't have the equipment to do it anyway. Like I would, if I were to make my own bolts, I'd want to like make really nice brass looking ones or something like that, and I would need a lathe and do metal turning and all that, and I don't have that equipment, so I can't do it if I wanted to. The intention is to try balance accuracy with ease of use. So the idea is if you got a bolt lookup table, from now on, if I need to make connections, I can just use the string to get there, to get the approximate, well, to get pretty accurate values there, right? That's the idea. I think it makes sense to do it that way. And let's just export this to see what it looks like in step file, because sometimes it doesn't work because the export's not perfect yet. It's a bit actually, the problem isn't with my export script. It's actually with how FreeCAD handles the implementation. So there are things you can do in OpenSCAD that render differently in FreeCAD, and you just have to make sure you know what's up. But that looks accurate to what I wanted to model. So the real reason to have this step here is it's some kind of visual indication of where the threads are. The rendering real threads, so the actual cut in the 3D model, would look really nice, but it inevitably slows down your calculations. It always ends up chugging things a little bit because it greatly increases the number of surfaces and curves on your model. And if you have to render it in a faceted manner, it has to tessellate a whole complicated helical structure. It's more trouble than it's worth most of the time. It looks really nice, but it slows your model down. So this is one way that you can sort of indicate that instead without trying too hard. And hopefully people understand by looking at it what it means. Usually people are capable of figuring it out, right? Like it's illogical that this would be threaded and this wouldn't. That doesn't really make any sense. So I figure by process of elimination, people can figure it out. Anyway, just a rough indication. Okay, so I'm pretty happy with that bolt stuff for now. So using that, I think I can add a bolt to let's add a bolt to the corner. I'm wondering if that's a smart idea. Oh, also, let's color the bolt. Here, color. I'm not really picking colors intelligently. I'm just kind of randomly doing a pattern of some kind. Ooh, that's a little weird looking. Also strange. Sure. Maybe bump blue. I'm not thrilled. I gotta stop messing with it. It doesn't even matter. Okay, so that's a bolt. Oh, let's undo this now. Okay. Corner. So I don't know. Let's just do this. Corner assembly. Should be okay. Oh, maybe not. See, bolts are kind of hard to know where to put because they're their translation positions do technically change depending on the thickness of the two things that you're bolting together, right? So you don't necessarily know which component to nest them with. So you should theoretically not put them anywhere until you're assembling stuff together, but then you have to do a lot of manual rework kind of stuff. So there's got to be kind of a more clever way to do that. I'm going to say I'll put them with the corners and deal with it that way. I do have to copy this though. Quarter-inch bolt, 2.5-inch long, maybe 3. Surely there's a function I could make. There might be a function I could make to ease this process a bit, but it's not jumping out at me yet. So for now, I won't worry about that too much. I also do realize there will be a problem. I'll have more bolts than holes because of how I made the corner. Huh. Be right back. Okay, let's see how I can get this thing working here. This corner assembly thing is the next thing to tackle. How can we do it? Maybe I'm overthinking it. Maybe it isn't a big deal. So just kind of put it where you think it is and tweak it as necessary. I'll see what happens if I just do that. First of all, let's just see what it looks like as is. Let's list corner, like that, and then bolts. That should render corner 4 1/4 inch is fine. And let's undo this bolt here. Oh, I did already. Okay, I can't see anything. Let's get rid of this. What did I mess up here? Okay, something's not working. Oh, calling the wrong function. Okay, so we've got the bolts lined up in the right positions on one face, not every face. That's also way too big. 2.5 inches. Why did I do that? 1. That could work. Right, so I need to flip them all. I also need to find a way to eliminate corner, like the outer corner bolts like that. So I only need a triangle. I don't need a full square grid. I'll figure that one out in a bit. Right, so the next thing to do here, I want to rotate it pi. That should flip them. Hey, there we go. And they have to be translated here, negative 0.5 inches technically, and that'll be, oh, it'll actually have to be, I don't know, like 0.6 for a washer to sit in there too, but that'll technically be enough. The piece of wood will be in between that, so that should work okay. And I don't need to put a nut on the end of this, because the current plan is to drill and tap these holes, so this plate will be threaded already. So I just need to figure out how to drop this bolt, because I don't need that one. Uncertain about that one currently. Well, let's assume that I can figure that out, and what I'll do is I need to make 2 more bolt sets here. I need to do some rotate magic, which actually should just follow this. The same set of rotations here should work. Set of plate I call bolts. See if that works. It does. All right, that's pretty promising. I'm looking pretty good so far. Let me now change this to panel assembly. Oh, what? Kind of working. It looks kind of correct. If we ignore this one here, because that's not a problem, I just didn't take it out of the code, so it's still rendering it in the middle there. Not a big deal. And if we ignore the floating one at every corner, it's looking pretty okay right now. I think I did something wrong with the panels. This has to be 1/8. Actually, this has to be through hole size for okay, so here hole diameter, what's 9 divided by 32? Yeah, okay, so I'll just use this as the indicator. So that should be okay. If I do here 0.14141 is close enough to that. Yeah, that's okay. That should gap things enough here. I could even do this 9/32. Oh, it's actually 9/64. I'll just leave it like this. 141's okay. Put a little note maybe here. The nominal drill size for 1/4 inch bolts to through fit is a 9/32 inch bolt. The radius of the holes is 0.141 in the panel part there. According to save it. That's pretty good. And typical washer thickness. Standard washers. We don't have 1/4-inch bolts. I think 1/4-inch bolts is probably too small. I probably need to go to 3/8 maybe. Also, this not a great site for it maybe. Washer thickness, please. Oh, these are metric. What? This sucks. I just need a rough number here for spacing purposes. Yeah, I don't know. .065. I'll use that. You'd think they'd have a spec sheet somewhere that would give you metric imperial for standard stuff. I mean, there might be something somewhere. I am just doing the lazy man search. I just am clicking the first few results. I'm not going super deep into it all. I mean, I'm sure if you look, there's a ISO standard that has stuff like that available, I would imagine. Or a engineer's or civil engineer's handbook of some kind that has all kinds of useful stuff in it. But I'm not looking for necessarily exact. I'm looking for a approximate. So like this here, for example, is a good enough indicator that the ballpark, I was guessing a 0.1, but that's 0.1 is too much. So I'm just going to go 0.065 as a good median here. Because there is a point where I don't need it to be that exact, but it is nice to have an approximate there. So, you know, it's better than nothing. So you would think that there is a standard. There probably is. I just don't exactly know where to look for it right now. Any place I've worked at, there's always been someone with a dusty old book that has all kinds of standard measurements in it. But I don't have a book like that. So I'm scouring the internet. That's okay though. It's not the end of the world here. And definitely I'll refactor this to be more concise with where all the dimensions end up going. I made so I was talking about my next YouTube video being about the tracing thing, but I changed my mind and I made a 3D model with this approach. And in that video, I have a parameters map, and all the assembly relates back to the parameters. So it's like nice and clean and built together to be nicely parametric. This is not currently like that. There's hard-coded values all over the place, and I'll just refactor that out at another time. So something like this, the washer thickness won't really matter. It'll be changeable somewhere else. But for now, I just put it in here. And I have to do it in the corner assembly. Here, this is going to be 565. Yeah. That should be okay. Oh, right. I still have that floating around there. I mean, how? I can't just like drop it from the list because now it's not just one thing. If I scale this up to 6 or down to 2, well, down to 2 it's fine, but yeah, I do need to figure that one out. Hmm. For X range 4, Y range 4, please. That makes a grid, right? X, Y. So that should be 16 elements, right? Yeah. But if I do, no, it's not commute. What's the, is it permutations? I forget now. Clojure permutations. I think that's in a different library. Yeah, combinatorics. Permutations, there we go. This is what I'm looking for. So let's see if I'm thinking correctly. Clojure.math.combinatorics/permutations. Is that going to work? Wait. Oh, do I have to? It's a separate dependency. That's a pain. That's also not what I need. Combinations is what I need. Right? That would only get me the diagonal, wouldn't it? Triangular. There's got to be this seems like I'm complicating things needlessly and I'm just not thinking about it properly. What am I trying to use this for? I am. So if I look at, let me clean up my render for a second and I'll explain what I'm trying to think my way through here. Okay, so this corner plate, right? Let me try to make it a little easier to see here. Oh, maybe that's harder to see. The corner plate has a whole grid cut out of it. So what I'm doing is, so I'm generating a grid, like a square grid, and I'm just cutting those holes through the plate. But because the plate is a triangle, the holes outside of the triangle they just disappear. They're not relevant to the shape of the piece. But I'm using the same grid pattern to pattern out the bolts. But of course, there's now a floating bolt here, right? So I'm trying to think about the right way to generate the correct grid minus the top part of that triangle. And I was just thinking if combinations or permutations would be the right way to go. I'm not sure they are, but does that make sense? I can't just drop the last bolt from the list either, because the corner component is parametric on its width. So in theory here, to fully bolt this thing down, you've got 1, 2, 3, 4, 5, 6 holes here, but I have 3 floating bolts here because the grid is the square 3 by 3, right? But I only need this 3 by 3 triangle of the grid. So I can drop the top corner of the grid every time. And I'm just trying to figure out a clever way to generate those XY coordinates without doing a bunch of extra work. But I can't see the, it seems like it might be obvious, but I can't think of it right now. I don't have the bounds. I can't do a bounds check. I mean, I'd have to implement that, and I haven't implemented that yet. Well, so I have bounds calculations, but that's in a different library, and I don't want to hack it into this one right now. I want to integrate things nicely. So I'm not going to hack in a bounds calculation yet. I'm also trying to think if there is a way to do it right in the for loop, you know? So like, I wonder, can you do... I mean, this won't change anything directly. Oh, I don't need to count it either. I'm just trying to think if there's a way. Right, so when x is 0, y is allowed to be 0, 1, or 2. When x is 2, y is allowed to be 2 only. Or, sorry, 1 or 2. I don't know. Maybe you're right. Maybe it is doing bounds checks is maybe the right way to go after all. I don't know. I am deciding that I kind of I let this bog me down a little bit. I want to start. I'm going to skip the assembly for now, the corner assembly, because I know what I have to. Well, I know I have to fix it. I wanted to try and make some kind of handle bracket, so maybe I'll start stubbing that in. Where are you making the whole grid in the code? Yeah, fair question. So here, no, panel's wrong. All right, let me have a look at the corner here. So corner is made up. Let's pare things down a little bit. Let's ignore corner assembly for the time being. Corner takes in a width and a thickness, and corner is 3 plates. Each of them are corner plate. So a single corner plate looks like this. The corner assembly just takes 3 plates and rotates them into different positions. So for the sake of this discussion, we can ignore the corner function. Corner plate creates this whole grid pattern, and it uses a for loop right here. So all it's doing is generating, in fact, if I change this difference to union, you'll be able to see the holes. See that? So what it's doing is Clojure's for loops, maybe you know this already. You can bind multiple things, and it'll give all the combinations of it, so you can use it to make every grid in a normal in a rectilinear grid very easily. So all I'm doing is generating x and y coordinates exactly like this, and then translating a cylinder copy to that coordinate for each of those. So even in the corner plate, I've got this extra corner, but because I'm doing a difference calculation, the cylinder that doesn't pass through a solid just gets ignored. It just doesn't show up at all. So it's a non-issue in this case. So I was using that fact to my advantage, making it just like that, right? You can imagine that there's a hole here, but a hole in nothing is still nothing, so it doesn't matter. But when I apply the exact same grid spacing to the bolts, it does put the bolt there. So what I would need to do is figure out a way to just get rid of certain XY pairs from the loop here. And I could just do, like I could guard it with a when of some kind, right? 0, 0 will always be the correct origin. So XY at 0, 0 will always be valid. It'll always be the upper corner that they're gone, if that makes sense. So this hole here you can consider to be 0, 0, basically. So I have a standard offset calculated for it, but just imagine it to be 0, 0. This is the 0, 0 position on the grid. This is x1, y0. This is y1, x0, right? And then this one is 1, 1, 1. Whoops. This is maybe a wild shot, but I'm wondering what happens if I do something like this. I wonder if I can use the sum of the two values as a filter. You know what I mean? Do I know what I mean? Oh wait, that's not what I want to copy. If I filter the coordinates as anything where x is greater than width over 2 and y is greater than height over 2, x and y greater than, would that solve my problem? It might. Let's see. I'm thinking. Well, let's just do this. Let's try when to guard that. So right now, when true, no change, right? Let's also turn this into union so I can see it. And let's, just for kicks, we'll make it 6 so we can see a lot of stuff going on here. So when and x half width, right? I guess that makes sense. We'll see. I'll be honest, my brain's slowing down in the afternoon today. I'm using width in both cases because it's a square shape. It's always guaranteed to be that. Oh, I have to, I did it. I have to invert this. I have to do not this. Right, so that's close. It's not quite right yet because, yeah, that's not quite it yet, but we're onto something, right? Because it's filtering the top corner in this case, so it's kind of there. What if it's just width? See, I'm at that stage where I'm not really thinking that hard. I'm just messing around with stuff a little bit, you know? Would it be width 3, 4? Yeah, see, it's a little picky, right? See, it works there, but here it's wrong, and here it's wrong too. So that's not quite refined enough, or at the very least, this has to scale with the width itself, if that makes sense. So let's go try this thing again. Oops. This feels like a solvable problem. This feels like one of those problems that it'll click, you know, at the gym or in the shower later. But I'm not getting it today. I have to go in about 10 minutes, so I'm not going to stress too much about solving it right now, but it's a solvable problem for sure. I just have to think about it. And you're definitely onto something with that filter approach. It just seems like I do have to pick, I have to scale this a little bit somehow. I mean, right now I'm just messing around. I'm just trying to pick a number at random, and that's not particularly useful, right? Hey, Zertroniker, hey. How's it going? I hope you're doing well. I'm thinking. It looks like I'm doing absolutely nothing, but I'm thinking, I promise. So this feels like something. But feels like something is wishful thinking, I think. What's new with you, Zertroniker? Hope you're doing well. Thanks for stopping by the way. I always appreciate that. This looks ridiculous. Why did I make the height of this cylinder so big? It doesn't need to be. It should be T. Oh, maybe not T. Oh, what? What? Oh, 2T, and I'll translate it up 1T, half T. There we go. That's fine. It really doesn't matter when you're doing a difference and you know you're going to do a straight cut through. It doesn't matter how long the cylinders are, but I think it's fair for debugging and stuff like that never to make stuff too ridiculous, because it gets hard to follow if it's like this massive thing or if it's too small. I would make it the exact right height, but when you difference things at the exact height, you get a weird Z fighting issue, so it doesn't look very good. That's a minor weakness with this system. But hey, it's not that big a deal. Okay, so in the case of, let's focus on this 6-piece case and try to come up with maybe something like this is a good scheme. I've got about 5 minutes to mess around with it and give myself some notes for the future, but that's okay. So in the case like this, we can imagine the sum of these things will be let me get rid of this and just true it for now so I see all the positions. So the sum of the kind of the grid indices will be 0, 1, 2, right? And then it'll be here 1 because of y, then 2 here, and then 3 where it needs to be eliminated, and then it'll go to 3, which is still, oh wait, is that right? 0 plus, no, this will be 2, and then this will be 3, and this will be 4. So 2 is the cutoff here. So in this case, the cutoff is 1 less than the max range. So if I do 4, let's imagine, and let's see if the cutoff is 3. Let's just check that out manually and see if that makes sense. Oops. Okay, so we've got 0, 1, 2, 3, and then this will be 1, 2, 3, 4 is the cutoff. Okay, so the pattern breaks there, right? Because we have y1, yeah, so that's 1, this is 2, right? Because it's 1 plus 1 is 2, yeah. 3 is acceptable. Oh wait, no, that does fit the pattern, right? Because 2 was acceptable last time, and now 3 is acceptable. Okay, so I think I'm onto something here. So let's see. Let's try that. When let's try something like that. That seems a little promising to me. Okay, so what do we have to do? When the sum of whatever is greater than, so when the sum of x and y is greater than some number, it would be decrement the width by, it would be width minus 2 in this case, right? Because we're stepping by 2. Does that make sense? We'll find out. We'll see if this gives a useful result at all. And I'd have to do not this, right? Let's see. Hey, that's exactly wrong. And when things are exactly wrong, you're one step away from being exactly right. Yes. All right, that I think is a fun bit of problem solving. I feel pretty good about that. Let's just invert it. Wait a second, can't I just do this? Will that work? Hey, no. Oh, I have to do greater or less than equal. Yes. Hey, you know what? That is a great way to... Well, oh man, that's great. I am proud of myself for that one. Okay, nailed it. Yeah, maybe it's a silly thing to be happy about, but that felt nice. That was a satisfying way to go through problem solving. Just break it down a little bit. Just take it one little step at a time. Now let's just apply that to the corner assembly here, to the bolt setup, and test it, and we'll be good. We should be good. Okay, that's the bolts. That looks good. Let's do corner assembly. Let's also fix this to difference again. Oh, it's a little ugly looking, but we are good to go. Yes. Oh, that's so satisfying. Mike, thanks for the hint. You put me on a good track there. What a great way to end the stream. You know what? I'm gonna quit while I'm ahead today. I have a YouTube video that I have to finish editing, and I want to see if I can get that out tonight. If not, it'll be out tomorrow morning, I hope. So I want to give myself a little bit of brain relaxation before I have to hit that grind. So yeah, that's going to be it for me for the day. Thanks everyone for tuning in. I always appreciate it. Nah, man, all me, 100%. You're there for the support. I feel good about that. Oh, that was a satisfying one. That's like, what do they call it? It's like nerd sniping, where you ask a complicated question or like you get people trying to figure out and solve things. It felt like that to me. Like I had to figure it out. Oh, man, satisfying stuff. All right. Yep, so that's going to be it for me for the day. Hey, Mike, thanks as always for tuning in and participating. Really appreciate that. Other people, I'm not sure anyone's tuned in at the moment. There were others earlier this morning, or earlier this stream, this afternoon. Thanks to you as well, and that's all I got. I'll be back tomorrow, ready for the weekend and all that stuff, but you know, it's gonna be good. I am gonna get going. Have a good one, and I'll see you later.